Hello everyone and welcome to your lesson of physics, and in this video we're going to have a revision past paper practice of the topic thermal properties of matter, which is from a section of thermal physics. Alright, so first of all, the most important thing from this chapter is mathematically you get two types of questions from here. First one we call phase change problem, a question in which phase or state of matter of an object changes. Temperature in that case remains constant. So it might be that solid gets converted into liquid, or liquid gets converted into gas, or it might be the other way around, like gas into liquid or liquid back into solid. In these kind of questions, you have a formula that you apply straight away. Q equals ml. What does Q stand for? In that case, Q stands for heat energy or thermal energy. M stands for mass. And L stands for the latent heat, specific latent heat. It might be specific latent heat of fusion. It might be specific latent heat of vaporization, depending on the question. Like in this case, it says the specific latent heat of fusion. So you can write F, small f in the subscript if you want, just for the reference. Otherwise, it's fine. Even if you don't write, that would be fine as well. Abdullah beta, I think it should be clear. I don't know why you can't hear me. Matter of fact, I have connected as a student as well. I've connected as on a receiving end as well, and it is fine. All right, so let us insert the values in it. Q, which needs to be calculated. M standing for the mass. Mass is given as 45 grams, which in kilograms would be divided by 1000. So you divide it by 1000, you get 0.045. You get the mass times the latent heat. All right, so here's the catch here. The latent heat that they have given is already in joules per gram. So we don't need to convert mass into kilograms because all of our data is in grams. So let us write mass in grams. Uh, is everyone having the same problem? Not being able to listen? I mean, you should jump to like 5 minutes. Jump to the fifth minute and around fourth or fifth minute. It might be still at the start. At the start, I wasn't saying anything. Yeah, so it might be the same problem. You should, or you can just click on the live. All right, you go to the status bar where you can see the timeline, time frame. Just click on the live button so you see the latest video. Yeah, refresh. And isn't the kg is a standard unit we are supposed to write the answer in? Saad, you're totally right about it. But the thing is, if you want to convert this thing, if you want to convert this thing into kilograms, then you would also need to convert this thing into kilograms. You need to convert both of them into kilograms. So instead of converting both of them into kilograms, just let them in grams, because your answer would eventually be in joules. The answer, final answer, because you're finding thermal energy, the answer would be in joules. So grams or kilograms is not even there. It's already being cancelled out in the processing. So why would you spend extra time in conversion? So that's why I'm going to write 45 into 220. Okay, generally we don't write units in the calculation, but just for the sake of understanding, you can say 45 grams into 220 joules per gram. This gram cancelled out by this gram. The answer would be 45 times 220. The answer would be in joules. Where is the question? Should be on the screen. This question is it's just a random question. It's not from a specific past paper. I don't know which year is it from. The next ones would be, I'll, I'll let you know which exact question that is. But this was just for a sample. I'm not sure about it. Like what year is it from? So 45 times 22. So 990 joules. Okay. So this was a phase change problem, the first type. The next type is the temperature change problem. All right. So what do we have in the temperature change problem? Well, in the temperature change problem, the temperature of the substance changes and the phase or the state of matter does not change. Only temperature changes. Forty-five. Yeah, we did that. 45 times 2 220. We did that. Oh, sorry. 9900. Missed a zero over here. Now it should be the final answer. Okay, so whenever you have a temperature change problem, the formula that we use is the simple one: Q equals mc delta theta. This is a formula for phase temperature change problem. Whenever you see a temperature change problem, straight away with the eyes closed, you can write down this formula. How do we know that it is a temperature change problem? Temperature was previously 500. It is now being reduced. It goes to 50 degrees centigrade when placed in the water. So previously it was at 500. Now the temperature has dropped to 50 degrees centigrade. So there's a big change from 500 to 50. Temperature changes. The change is 450. So you write down the mass here. Mass is 2 kilograms given right over here. Specific heat capacity 460 kilograms joules per kilogram per degree centigrade. So specific heat capacity is also in kilograms. So totally fine with it because mass and the specific heat capacity are in the same unit times the change in temperature 450, and then you simply hit it on the calculator. So 460 times 450 times 2, 414000. All right, it would be recommended that you better write the answer in consistent number of significant figures, like in two significant figures, but that's also fine. That's totally fine as well. If you want to write in 2SF, you can write in 2SF, but the marks would not be deducted in this paper. But in paper 4 in ADP, you have to be careful with the significant figures. So if you're writing in uh, uh, accurate number of significant figures, then that would be your answer. All right, now this is we are starting with the past paper question. This is the most recent question from 2021, paper 2-1, May June, question number 3. So those who are having the past paper, you can find it in the yearly past paper 2021 May June paper 2-1. It is question number 3. So steel rod is cooled by plunging it into cold water. The steel rod, or it's the same one that we have just solved. We apply the formula Q equals to mc delta theta. So anyone who was asking what question was that, this is from year 2021 May June paper 2-1. So the answer to this one was 414,123 joules. All right. Anyway, the next part B says, B part 1, state one way in which boiling is different from evaporation. Yes, anyone who would like to answer that? I'll be looking at the chat box. Anyone who can state one difference between, no, Ibrahim Beta, that is not included. Okay, very good. Boiling occurs at a certain or a specific temperature, whereas evaporation okay, boiling occurs throughout the, yes, that's totally right, but try to relate it to a context. Try to be specific. Boiling occurs throughout the liquid. That's totally right. Sufficient energy is supplied in boiling. Yeah, you have to supply a certain amount of energy, Before supplying that certain or specific amount of energy, the process of boiling cannot start. Yeah, boiling doesn't cause cooling. That's totally right. Whereas evaporation can occur at any. All right. Anyway, the rate of evaporation decreases as the water cools. Explain why this happens using ideas about molecules. So the fact they have stated themselves, um, I don't know about it. It can be, cannot be. I mean, it would be unfair if I do any of the comment. All right. Anyway, so if you decrease the temperature, if the water is cool, all right, molecules have lost some of the energies. They don't have enough energy to escape from the surface. So how do we write down? We have to phrase it properly. So we say average energy of the molecule decreases. Molecules decreases, and they don't have, the next pointer would be, don't have enough energy to escape the surface. To escape from the surface of the liquid. It's evaporation, that's why we are writing in terms of the surface. Had it been boiling, we would have been saying to escape from the liquid or escape through the liquid. The particles with greater energy have already escaped. Okay, very good. This one is from October, November 2021, paper 2-1, question number 9. All right, so it's another recent question. Liquid and glass thermometers use the expansion of a liquid to indicate the temperature. Figure 9.1 shows the molecular structure of a solid and a gas. In the middle box of figure 9.1, sketch the diagram to show molecular structure of a liquid. All right, anyone who can give any hint about it? What would be, what would the molecules of a liquid look like? So it would be just in uh, an intermediate phase of solid and gas. Not too close and not too far apart. If they are too close, that would be a solid. If they are very far apart, then it would be a gas. Yeah, slightly loosely packed. So explain why it is easier to compress a gas than to compress a solid. Yeah, anyone who would like to respond to it? Okay, because of its density. Mm. Uh, See, it is easy to compress a gas because when we are compressing, we are bringing the molecules close to each other. So you think about it, for a gas, if I'm to compress a gas, then I'll bring these molecules towards each other and I'll be reducing this space. So all this extra space would be eradicated, all the extra space would be removed. But if you take a look at the solid, if I have to remove the extra space, the question would be there is no extra space in the first place. There's no extra space as compared to the extra space that the gas molecules have. So that should be the answer of it. Okay. Particles far apart can be brought together as for solid. Yeah, that's totally right, Sad. That's totally right. More space between molecule. In gas, molecules are far apart. They can be brought close together. And for the solid, in case of the solid, there's not enough space, not enough space for the molecules to be compressed. So you can complete the phrase. The temperature of a liquid in glass thermometer increases. Say two ways in which molecules of the liquid in the thermometer are affected. So you increase the temperature, what happens to the molecules? Uh, the thing is, Moving the thing is, in the past paper, they have the questions from specific latent heat, and then they combine those questions. They ask question about heating curve, cooling curve, which is the old syllabus. And these are the latest. I mean, I have not compiled these questions by myself. These are the recent questions, and to consistent with the updated syllabus. So you should confine yourself to the questions of this pattern. All right, anyway, what are the two ways in which or by which the molecules would be would be affected? Anyone who would like to respond to it? Pressure increases. Okay, molecules expand. And when I say the word molecule expand, so let's say this is a very important pointer. These four molecules are there. When I say the word molecules expand, okay, it doesn't mean the size of the molecules increase. No, that doesn't mean by expansion. When I say the molecules or the substance expands, it means the spacing, their size remains same, but the spacing between them increases, right? Only the spacing between them increases. So you can either write spacing increases, all right, or you can also write the kinetic energy increases, or the speed or velocity increases. All right, yeah, totally right about it. All right, May, June 2012, 2011, paper 2-1, question 3. Explain using ideas about molecules why a balloon filled with gas expands when heated. Yeah, I'm looking at the chat box. Anyone would like to respond to it? Okay, so balloon filled with gas expands when heated. So what's the reason? First of all, the molecules, all right, when you heat it up, their kinetic energy or the speed would increase. They would apply more force and more pressure on the walls of the balloon, on the balloon itself. They apply pressure, and due to that, the balloon will expand. So these are the important answers. Just note down these one as well. Kinetic energy of the molecules increases. More vigorous clay and collide with the wall kinetic. Yes. And matter, there's a trick about it. Try to write all the relevant facts about the answer. Whenever you have 2-3 mark question, try to write as many independent facts as you can. Because even if you write something wrong and you stated 3 correct facts and 1 wrong fact, you'll still get full marks, because for the incorrect facts that you have stated, they are not going to cut the extra marks, provided that you have stated some correct facts as well. So due to that force, pressure is exerted, and due to that, right, say on this balloon, the molecules were applying pressure, and once they were applying the pressure to the sides on the walls of the balloon, it would move the balloon out. Yeah, these are enough. Yeah, just once you have figured out how many facts you're going to write, just write them in description. Okay, so I've written down the answer in the bullets, just make description of it. Why a balloon filled with water expands very little when heated as compared to a balloon filled with gas? Yeah, totally right. Water expands very little. All right. So you're trying to heat up the water. You're trying to expand or increase the spacing between the water molecules, but the problem would be the two water molecules, they are holding each other too tightly that you're not able to overcome that force easily. So intermolecular forces are too strong. All right. Now, once again, we have a mathematical question, 2 marks. For 2 marks, a bubble of gas rises from the bottom of the lake to the surface. Okay, whatever. This is one value of pressure. This is the second value of pressure. This is third value of the third value is of volume, and you need to find the second value of volume. All right. The two values of pressure are given. One value of pressure volume is given, and one value of volume has to be calculated. So the first one you can call it P1, this one you can call P2, this one you can call V1, and V2 needs to be calculated. Yes, definitions are always included. Matter of fact, if I be very honest, 40% of the paper of your P2 is based on facts, figures, definitions, and explanations directly related to the definition. All right, so we had a formula that I said P1 V1 over T1 equals P2 V2 over T2. Then I said if two of the three things are given, then you can simply ignore the third one. So there's nothing about the temperature, so you just ignore the temperature. The remaining formula would be this one. This would be your remaining formula. Exactly. Yes, Momina, you're right about it. So I can write P1 V1 equals to P2 V2. So what is the first value of pressure? 3.0 into 10 to the power 5. This was the first value of pressure into the first value of volume V1, 2.0 into 10 raised power, sorry, just 2.0 equals, what is the second value of pressure? Well, it's given over here, into 10 raised power 5 times V2. V2 stand for the second value of volume, which needs to be calculated. Now I'm just doing some mathematics, don't get confused with it. You can hit it on the calculator your own way, but what I'm going to do is cancel out this thing by this thing, and 3 times 2 would be 6. So 6 cubic centimeters. How do I know cubic centimeters? From here. All right, the next part says state one assumption that you have made in your calculation. We ignore T. All right, you see in the original formula there was a mention of temperature as well, but we have ignored temperature, and we assume that the temperature remains constant. The temperature doesn't change. That's why whatever the temperature, let's say 10 Kelvin was here, 10 Kelvin here as well, and then it would have canceled out automatically. This is what we assume, that the temperature remains constant. Temperature of the of the gas bubble. All right, temperature of the gas bubble remains constant. Yeah, that the temperature is constant. All right, so the question would be, all right, you should be asking me the question, if we are using a formula, we're solving a question in which there was a mention of temperature as well, and the temperature also changes, and we are applying the total formula, the whole of it, including the temperature, then what is the assumption there? What thing is constant in that case? Because the temperature is also changing, pressure is also changing, volume is also changing. So what is the constant thing? And the answer in that case, mass of the gas is constant. So matter of fact, you could have written this thing as well. Mass of the gas remains constant. Or in that case, mass of the gas bubble. How do you made that assumption? We made that assumption because we excluded this thing. Okay, there was a mention of temperature in the formula. In the standard formula there was a mention of temperature, but how can you get rid of a certain quantity from the formula? You can only get rid of that quantity if that quantity does not change, if that quantity is constant. Only then you can get rid of that quantity. So this is what we have done here. We have assumed that temperature does not change, so that's why we do not use temperature in the formula. Once again, a recent question, May June 2021, paper 2 question 9, part C, right? I'm just doing the part C because the other parts were about something else. It was related to conduction, convection, and radiation. So you need to find thermal energy. Thermal energy, the first thing, you have two formulas for thermal energy. Q equals ml and Q equals mc delta theta. Which one of these two formulas do we use here? Which formula is compatible in this case with this question? Yeah, anyone who can respond to it? The hint would be here. Hint should be here. So because it says that the temperature rises, it means it is a temperature change problem. All right. So I'm going to raise off the other one. As a matter of fact, I'm going to rewrite it. The temperature change problem. Because in this question, the temperature changes, the state doesn't change. Yeah, thermal capacity. Thermal is a Latin word for heat. So it's just the same thing. Heat energy or thermal energy. So mc delta theta. So Q, thermal energy, you need to calculate, just write it down as it is. What is the mass of the battery? The mass is 1110 I'm going to write it as 0.110, and the specific heat capacity is 830 joules per kilogram. Now, the thing is, in the very first question, I used the mass in grams as it is. Okay. I use the mass in grams as it is, but in this one, I can't use the mass in grams as it is. Why? Because a specific heat capacity is given in kilograms. So either you need to convert this one into kilograms, into grams, and your mass would be in grams, or it's better just convert the mass into kilograms. And what is the delta theta? Delta theta is the change in temperature, which is the temperature rises by 5 degrees centigrade. So the change in temperature is 5. So this is the total energy that you're supplying. In that case, I'm going to hit it on the calculator. 456.5. 456.5 or 460 joules. All right, and this will be the last question for today. Question number 5, once again, quite a recent question, 2020, October, November, paper 2 on question 4. Why is your point? Okay, let me get back over there. First of all, I'm not going to solve this one for now. Obviously, it is related to something that we have studied previously, efficiency. You can define it, total useful output energy divided by total input energy, and calculate efficiency, just insert the value, but that's not part of this chapter. Why do we use? Because we converted mass into kilograms. We converted it into kilograms. Why do we have to convert it? Because this time we need to convert it because specific heat capacity is also given in kilograms. That's the reason. Okay. Describe in terms of molecules the structure of the solid. I'm going to write the bullet. Molecules are in fixed place. Was that clear, Momina? Why are we using 11, not using 1110? Yes, that's the right thing. That would be the only thing that you need to consider. If the specific heat capacity is in kilograms, mass should be in kilograms. If the specific heat capacity is in grams, mass has to be in grams. All right, molecules are in fixed place. Molecules form a regular pattern This will be your second pointer. And the third one, you can write molecules are close together or tightly packed. Yeah, tightly packed. Good mirror, pen, Momina. All right, the next part B shows figure 4.1 shows a metal worker hitting a horseshoe at a horseshoe magnet at, or it may literally be a horseshoe, sorry, not a magnet, it is a horseshoe, to a high temperature before shaping it. The metal worker then cools the horseshoe by dropping it into 8 kilograms of water at 18 degrees centigrade. The final temperature of the water is 43. Specific heat capacity of water is that much in kilograms. Calculate heat energy transferred to the water. So again, once again, heat energy, it is the question in which we have to apply one of the formula, Q equals to mc delta theta or Q equals to ml. So which one do we use, Q equals to mc delta theta or Q equals to ml? First one or the second one? Yeah, we'll be using the first one, not the second one. So Q equals, now what is the mass given? 8.0. What is the specific heat capacity? 4200. It's also in kilogram. This is, and these two are in kilograms, so no need to convert anything, into delta theta, and delta theta is 43 minus 18. Okay, 43 minus 18. Do we have to memorize experiment to find? Yes, you have to, because from this year, from 2023 syllabus, they are going to explicitly ask you for a question about designing an experiment. So why would you design, like, or why would you write yourself once you already know an experiment? So it would be better just to be on the safer side. You should be able to know all the main pointers. I'm not saying like memorize the word to word, but memorize the key pointers, right? Just to be on the safer side. So in 2SF, the answer would be, all right, in 2SF, 840,000. So heat capacity, sorry, specific heat capacity, you have to know each and everything about it in detail. Heat capacity, the latent heat, specific latent heat, just try to memorize its definition and the standard formula for those who have to appear in 2023 onward. And those who have to appear in 2022 exam, they have to study specific latent in details as well. All right, everyone. So that is it for today. Uh, I'll be seeing you in the next video. Take good care, everyone. Allah Hafiz.